Okay, at this point you should have had an opportunity to try the practice on your own, and now we'll go over the answers. So I put a periodic table here so that we could recall the trends in atomic radius. So I'm going to call atomic radius, I'm just going to abbreviate that AR. So our trend in atomic radius is that as we go across the periodic table from left to right this way, it decreases. And then as we go down the periodic table, atomic radius increases. Okay, so this is the trend that you need to memorize in atomic radius. Okay, so let's look at our first question. And remember, this is asking which radius is larger. All right, so I'm going to find lithium on the periodic table, lithium and potassium, K. All right, so I see that potassium has more energy levels. It's in period 4. So I know as I go down the periodic table that atomic radius is going to increase, so therefore the radius of potassium is larger. Okay, now we have calcium or nickel. I haven't found a good way to erase, so we'll just have to bear with me while I do that. Okay, so calcium or nickel. So calcium, and then nickel is over here. So as we go across the periodic table, atomic radius decreases. So therefore, nickel is going to have a smaller radius than calcium because they're in the same energy level 4. So calcium is going to be larger. All right. Then we have gallium versus boron. Gallium is over here, number 31, and boron is up here, number 5. So which one is going to be larger? Well, as we go down the periodic table, this is group 13. It gets bigger, the radius gets bigger, so gallium is going to have a larger radius. And then we have oxygen versus carbon. So oxygen, and then carbon is also in period 2. So we know that carbon is going to be larger. Chlorine versus bromine. So we have chlorine here versus bromine, which is 1 period down. So as we go down the periodic table, we get larger, so bromine is going to have the larger radius. Then we have beryllium or barium. Beryllium is number 4. Barium is number 56, also in the same column or group 2. And as we go down the periodic table, we get larger. Barium is going to be larger. Then we have silicon or sulfur. Silicon over here is a metalloid, and then we have sulfur, which is a gas. In the same period 3, so we know sulfur is going to be smaller, so therefore silicon will be larger. And lastly, we have iron and gold. Gold is farther down the periodic table, so we're adding energy levels here. This might not be obvious since we know that iron is farther back, so that means it could be larger, but because we're adding energy levels, gold having 6, being in period 6, it's actually going to have the larger radius. Okay, so now let's look at the ions themselves. So let's start with, let's just review. I have it written up here. So remember, cations are going to be smaller than their neutral atom. Anions are going to be larger. So let's drill down on oxygen as an example for an anion. Okay. Oxygen has 8 protons. See, it's number 8. Okay, so 8 protons. And that means in a neutral atom, it's going to have 8 electrons. So we put 2 in the first energy level, and then 6 in the second. So 1, 2, 3, 4, 5, 6, 7, 8. So that's our 8 electrons. Okay, so this is just regular neutral O. And now when we make O minus 2, the anion, it's going to be the same thing, same 2 energy levels, but this time we're going to have our 6 but we're actually going to have 2 more because oxygen gains 2 electrons when it becomes an ion. Okay, so that means we're going to have more repulsion between those negative charges because we're not adding any more positive charges. So that's going to mean that the anion gets bigger. Now, over here it's asking you which one has the smaller atomic radius. Okay, so then that means that compared to the neutral atom, the anion is going to be bigger, so therefore O will be smaller. All right, now let's look at a cation. Let me go back to red. Let's look at lithium, our next option. So lithium has 3 protons. So 3 protons. It's going to have 2 electrons in the first energy level. 1, 2, and then 1 electron in the second energy level. Lithium is in the second energy level. So this is neutral lithium, and then let's look at it when it becomes a +1 ion. So lithium still has those 3 protons, but this time it's lost an electron. So cations lose electrons. So it just has that 1 energy level. So now it's got these 3 protons pulling on just 2 electrons. So it's going to pull them in really close. Okay, so it's got more attraction. There's greater mass, greater positive mass than negative mass. Okay, so our cations are going to get pulled in closer, so they are smaller. All right, so which one's smaller? The cation. All right, so let's follow that same trend with aluminum. So we have aluminum +3 or aluminum neutral ion. It's a cation, so it's going to be smaller. So which one is smaller? Aluminum. Now we have potassium +1 or cesium +1. So cesium is here, and potassium is has 2 less energy levels than cesium. So which one's smaller? Potassium. It's farther up. We can use our trend and atomic radius. Okay, lastly we have 2 different cations that iron makes. So if iron has lost 2 electrons here, but 3 electrons here, this one's going to be smaller because it's lost more positive charge. It's going to be pulled in smaller. Okay, I hope this helps.